We briefly introduce joint learning of blind super-resolution and crack segmentation for realistic degraded images accepted at IEEE Transactions on Instrumentation and Measurement 1024. Automated crack detection is a crucial technology to streamline inspections of buildings, pavements, bridges, tunnels, and more. In this study, we particularly focus on crack segmentation in images captured with general-purpose cameras. Various imaging systems, such as UAVs or specialized vehicles, are employed for crack detection depending on the target. However, each imaging system is susceptible to motion-induced shake or vibration during capture. As a result, degraded images are captured instead of the expected clear, high-resolution images, making crack detection more challenging. We tackle this challenging problem. We present the results of our proposed method, CSBSR. These images are degraded low-resolution images. CSBSR processes into stages blind super-resolution and crack segmentation. First, in the blind super-resolution process, while estimating and considering the degradation factor, the blur kernel, it restores the high-frequency components necessary for crack segmentation. Lastly, the crack segmentation process estimates the segmentation of cracks from the obtained super-resolved image. This achieves detection that was difficult in the input image. CSBSR also showed superior performance in quantitative comparisons with conventional state-of-the-art methods. To demonstrate that our method is not limited to crack segmentation but can be widely applicable, we also validated in retinal vessel segmentation, a task different from crack segmentation. In this validation, we assume that images are degraded and low resolution during capture. CSBSR successfully enhances images and achieves segmentation of fine vessels. For those who want to know the specific algorithm details of our CSBSR or want to try the program code, please check here.